All right, everybody, welcome to the video here for the statistics review. So far we've learned a lot about statistics, and we want to just kind of quickly go through and review a couple key concepts here. So for the first question, this is our normal CDF question. I know it's normal CDF. It talks about normally distributed data. It tells us some info about the mean and the standard deviation. So we want to be able to determine some different points here. So the first thing says, what is the probability that a high school baseball game lasts less than 115 minutes? So if we're looking at our bell curve, I want to figure out the z-score for 115. So to find the z-score here, we're going to subtract 115 minus 105 and divide that by 11. That's going to give us the fraction 10 over 11. If we put it in as a decimal, it's fine. I like the fraction because it's an exact answer. So what I'm trying to figure out is, what's the proportion that's smaller than that? Now notice this goes on forever, but with statistics, we only care about the negative 10 z-scores. So if I normal CDF this, so if I make the lower number negative 10, the upper number 10 over 11, and type it into my calculator, I get a probability of 0.818, so about an 82% chance of happening. For part B, it says, what is the probability that lasts more than 100 minutes? So I'm going to put in 100 for the value, subtract the mean, and divide by 11. So it's going to give us a negative number, so negative 5 over 11. So when I'm looking at my normal curve here, we're looking at the percentage that's more than that, so it's going to go up to 10. So I'll make the lower number negative 5/11, the upper number 10. And if I do that, normal CDF in my calculator, I get 0.675. Part C is kind of tough because you had to do two different z-scores. So we need to do the lower z-score using the number of 90. Which gives us negative 15 over 11. And we need to find the upper z-score, which gives us 5 over 11. So when we're looking at our bell curve, I'm looking at a section that's between those two numbers. So I'll make the lower number negative 15/11, the upper number 5/11, and we get a probability of 0.589. Number 2 talks about in problem 1, we have this approximately normally distributed baseball mean time, and then we want to compare that to a softball time. So if the softball time is 95 minutes and the baseball time is 105 minutes with the same exact standard deviation, we're going to have a chance that's slightly higher of a baseball game being between 100 and 110 minutes compared to a softball game, because the overall mean of all the data is 95, which is outside of that range. Now to calculate that, we have to do some z-scores. So for baseball, the lower z-score for baseball is going to be 100 minus 105 over 11, so negative 5/11. The upper z-score for baseball is going to be 110 minus 105 over 11, so positive 5 over 11. So that is going to give us a 0.351 chance if I do normal CDF. That's for baseball. So for softball, if I find the lower z-score, I have 100 minus 95 over 11, so negative or positive 5 over 11. And the upper z-score is going to be 110 minus 95 over 11, which is 15/11. If I do that, I get 0.238. So I see that the baseball probability is higher. And again, the reason why is the mean is within this range that we're looking to be in. Number 3 talks about eye color, and we're estimating the, or not eye color, I'm sorry, whether or not you close your eyes during a test or not. So we are finding the first 50 students arriving at school. And of those 50 students, we're flipping a coin to determine whether or not they will close their eyes during a test. And then you compare the results and see if your estimation is correct. Now, the thing about this question is, if you just choose the first 50 people that come into school, you did not really randomize anything. All right. So is this sample random? The answer is no, because it is not representative of the population. Right? If you think about it, right, when you're coming into school in the morning, a bus gets dropped off, all of those kids are going to be from the same area. So if you're living in the same area of, say, Cornwall, you're all going to come from the same exact demographic area or background. All right, so we'd want to try and find a population that's representative of all the students in the school. So you want some kids that live in New Windsor, some kids that live in COH, some kids that live in Cornwall. So you'd want to randomize the sample that way. A better way of doing this would be asking every fifth student that walked in the door for the entire morning. That would produce enough random samples where you'd have a representative sample of the population. Part B says, did the study make use of random assignments, right? The answer to that is yes. Random assignment is how they assign the people. So by flipping a coin, right, that becomes random. So because you took 50 people, you flip the coin, and whether or not they land on heads or tails determined on whether or not they open their eyes or close their eyes. I randomly assign which ones were in the test group and which ones were in the control group. That part of it is random. The part that was not random is how they selected the 50 people. Now, the last question is this observational or experimental? It's an experimental study, and the reason why is you have cause and effect, right? Does closing your eyes affect your outcome on your test or not? Right? So we have two groups. We have a control group that doesn't close their eyes, and we have a test group that does close their eyes. Number four gives us a sample proportion. So again, on your quiz, you're going to have to do 3 of these. One of them is going to be a proportion like this one. One of them is going to be sample mean. So all these numbers on the bottom will be means. And then one of them is going to be a difference of sample means. So all these numbers on the bottom will be differences of sample means. No matter what, if we're asked to find margin of error or confidence interval, we're using the information in the box or in the chart. So here it asks us for the margin of error, and that's going to be 2 times the standard deviation, which is going to be 0.032. So that's going to tell us our variability, right? How much are we varying to conclude for 95% or account for 95% of the data? So if I start at 0.5 and go up by 0.03, I'd be like here. If I start at 0.5 and go down 0.03, it'd be like here. Well, that's going to be about 95% of our data. What would happen if the sample size was increased to 2,000 instead of 1,000? Big concept here. As the sample size increases, the standard deviation decreases, meaning the margin of error decreases, meaning the variability decreases. So as soon as standard deviation decreases, all of your data gets closer to center, meaning your margin of error gets closer to center, meaning the variability or how close the data is going to get even closer. So as the sample size increases, all those things decrease in size. Last question, number 5. So number 5 gives us the 2 different groups, group A and group B, or group 1 and group 2, I'm sorry. Notice the results for group 1 are slightly higher than the results for group 2. So there's going to be some kind of change that happened here between these 2 groups. We can even see that the mean is different between group 1 and group 2. So because the mean is different between group 1 and group 2, we could test to see whether or not these 2 groups were affected by something. So part A says, based on the output, which is a reasonable normal curve, right? So the one that looks like a normal curve would be group 2. Right, if you look, that's a normal curve, right? This one seems to be slightly skewed to the left, right? Some of these outliers down here are skewing our graph to the left. Now, if you calculate the difference of sample means, you get a difference of sample means of 4.88, which means group 1 has an average that's 4.88 larger than group 2, when we're talking about the number of seconds of reaction time. Now it says, explain one reason why this claim is potentially misleading, right? So far, there is no comparison of sample means. Right, so I never found the difference of sample means and then redistributed to see if there was an actual true distinction here between the 2 groups. I just know that one group is 5 more than the other. I don't know how we chose the groups. I don't know whether or not this difference is outside of the plausible interval. I have no idea because I've never re-randomized. So part C says, what could you do to conclude whether or not group 1 and group 2 have a significant difference or not? So I'd have to re-simulate this or re-randomize everything and calculate the difference of sample means and make a new dot plot. So what that's asking you to do is take all of these dots, reorder them into different groups, and then find the difference, and then do that again and again and again and again, and do that like 100 to 200 or 400 times to create your own dot plot. And all these dots on this new dot plot would be the difference of sample means. And then you could determine if your diff of 4.88 was really outside of the plausible range or within the plausible range, right? Now notice I'm not asking you to do that, I'm just asking you to describe it, right? But that's basically what we went over in lesson 12. Hopefully this video helped and you're studying for your quiz tomorrow. Good luck with everything, and make sure you have all of your homework done because I'll be checking your books tomorrow.